My name is Kim Yates. I'm a research oceanographer at the U.S. Geological Survey St. Petersburg Coastal and Marine Science Center. PICES stands for Processes Impacting Seafloor Change and Ecosystem Services. And the PICES project that we're talking about today is actually our physical PICES project. So we're working on and talking about physical processes impacting seafloor change and ecosystem services. This project, the PICES project, the physical and biogeochemical piece, were actually born out of a full career of work. About in 2013, I was actually working in the Florida Keys, and I got into a heated discussion with a boat captain because we wanted to put some chambers on the seafloor. We were looking for a spot, and I jumped in the water and I was swimming around looking for a spot, and the boat captain had promised to come pick me up when I found the spot. So I found the spot and I waved him down. And he wouldn't come get me, and I was far away from the boat. It was because he said the water depth was too shallow. And I'm like, it's 12 feet deep there. And he showed me the chart. He says, no, it's only 2 feet deep. I was like, well, you have to come look at it. So he got in the water and swam over with me, and sure enough, we were missing 10 feet of seafloor in that particular location, according to the nautical charts we were using. So that's when I made the first discovery that there was substantial seafloor erosion going on in these carbonate systems that had been completely undocumented. We had known for years, in fact since the 1970s, that coral reefs were degrading, and many of the causes as to why they're degrading, but people had completely missed the fact that they were degrading so much that it was affecting growth of the entire seafloor in these ecosystems. We have a team of people who developed what we call georeferenced structure from motion system, which is called SQUID-5. SQUID-5 stands for Submersible Quantitative Underwater Imaging Device with 5 cameras. And what this allowed us to do was to collect very, very, very high resolution bathymetry or seafloor elevation data, and also take pictures at the same time. And essentially what it is a floating platform that has 5 cameras that are situated at different angles, and then also an onboard GPS system. And when you tow that over the reef, it takes pictures very rapidly from all 5 cameras, and because the positions of those cameras are slightly different, it can be used to build 3D imagery. For right now, the Keys is the main location for this project. Our office in particular has decades of research that has been going on in the Keys that help supplement this project by way of, the geologic history of the coral reefs. They are well known, and we collected a lot of that data. We have a number of ongoing studies, with respect to ecosystem processes and carbonate budgets and all sorts of stuff. And so the data that we're collecting in the Florida Keys actually helps support many of those projects.
I'm Dr. Lauren Toth. I'm a research oceanographer at the St. Petersburg Coastal Marine Science Center. And I study the process of reef growth over periods from decades to thousands of years. This is a new study that we're starting that's following up on a study that we just finished up that was looking at the history of reef growth in the Florida Keys over the last several decades. And one of the big findings of that study was that if these theoretical coral restoration targets are hit, then reefs could start growing as fast as they did 7,000 years ago. What we're hoping to do with the research we're doing right now is to see how that's playing out in reality. So we're going out to reefs where restoration is actually happening, and we're trying to measure those reef growth processes in real time. We're going out to these reefs where we have people who are down counting fish, folks who are counting sponges, people counting urchins, and then we're also taking underwater imagery of the reef so we can see what the corals and the other organisms living on the bottom are doing. And then we put all that information together into this carbonate budget that tells us about reef growth. So
divers can go out where we've already collected SQUID-5 data, and then they can use our georeference data to do what we call georectify their diver-based imagery. So that allows them to use our data to apply accurate positioning to their data, which means they can go back year after year to that same place and measure change over time on their own.